An article was published in Nature Communications on the 13th of August 2018 entitled Universal Holonomic Quantum Gates over Geometric Spin Qubits with Polarized Microwaves. Basically, they found they can manipulate the geometric phase of an entangled electron and nucleus of an atom using polarized electromagnetic waves. They used microwaves in this experiment, but it should be possible also to use laser light, which is also highly polarized. The important thing is that they used a carbon-based semiconductor doped with nitrogen to build these quantum gates, and they performed this experiment at room temperature. This immediately brings up comparisons with the DNA, which is also a carbon-based semiconductor doped with nitrogen and hydrogen atoms, which operates, of course, at body temperature. Also, recent research has found that room temperature quantum dots display highly efficient single photon emission with optical coherence times as long as 80 picoseconds. The researchers found that the quantum dots could emit photons very quickly after being stimulated by a laser beam, and that the quantum dots had very little interaction with their surroundings, enhancing their coherence properties and stability. Bear this in mind when we get onto the fact that the DNA acts as a solitonic holographic computer. Solitonic means single photon emission. A quantum dot is essentially an atom trapped in a one-dimensional nanoscale space. Most scientists trying to build a quantum computer have a background in quantum mechanics and computer technology, and they've rolled up their sleeves and said, right, let's make a quantum computer. So they built these bizarre-looking chunks of equipment that cost millions of dollars that contain vats of liquid nitrogen so they could house their qubits at almost absolute zero temperature, without apparently realizing that at that temperature light and all electromagnetic radiation slows down to about 15 miles an hour. Yet they persevere, notwithstanding the thousands of research papers that light displays quantum effects at room temperature, including fundamental stuff like the two slits experiment and all the research using light polarizers. The decisions an horizontally polarized photon will make if it's put through a vertical polarizer, for instance. In fact, the decision that it makes corresponds to the qubit now being a particle in the state of zero. Don't tell us about fundamental mysteries of life, they say. Just tell us how to make a quantum computer. And they've hit a brick wall, or in their lingo, an infinite potential barrier. The problem is this difference between a Turing machine and a quantum computer. The equations a Turing machine can solve don't involve consciousness, but not so for a quantum computer. Unless a conscious being makes an observation, the qubits are not even particles, but are just probability waves. They are not real. They have no physical reality. I can't stress this enough. So in order to make a quantum computer, they will not only have to solve this question of wave-particle duality, but they will also have to solve this problem of consciousness. It's only an observing conscious scientist that can make these qubits real. Schrödinger in 1943 addressed this problem when he asked, what is life? And in that same year, unbeknown to him, Turing made the first computer. If Schrödinger knew then what we know now, he would have answered his question with a simple Aristotelian first principle. Life is consciousness. Consciousness is generated by a quantum computer. Ergo, life is computer processing. More than 20 years ago, Roger Penrose observed quantum effects in microtubules and surmised this might have relevance to consciousness. What he didn't tell you is that these microtubules are ubiquitous in biological living systems, even in plants and blue-green algae. Also, microtubules are actually electrically conducting nanotubes. So if the quantum effects have some relevance to creating consciousness, then the parsley in your herb garden is conscious, as is the blue-green algae in the stagnant drain the next block over. In other words, all of life is conscious, and it is generated by quantum effects in every living cell. We find ourselves 76 years after Schrödinger posed this question, and most biologists know nothing about quantum mechanics, and most physicists know or care little about biology. Indeed, the technology sector is led by a bunch of transhumanists, not mentioning any names, who plan to upload their brain onto a computer and kiss off biology altogether. I told you that researchers have now built holonomic quantum gates at room temperature, and they are using polarized microwaves to manipulate the electron nucleus entanglement of an atom. Should we use the hydrogen atom as the qubit, then the similarities with the DNA molecule become striking. The DNA molecule is essentially a carbon-based semiconductor with nitrogen and hydrogen as doping agents. The fact is the DNA molecule absorbs and emits light. It's my guess that it's precisely the electron in the hydrogen bond that is pushed into the conduction band by visible light. In other words, laser light would push the hydrogen electron into the conduction band. When these electrons fall back into their holes in the valence band, they emit light at very precise frequencies according to the spectral lines of atoms developed in quantum mechanics. A spectral line at a very precise frequency is essentially laser light. It's totally monochromatic, and it's my guess that you could read whether the electron is spin up or spin down using this laser light. Years ago, some Russian scientists did experiments shining laser light through DNA. A specific wave pattern appears on a screen behind the DNA. It's my guess that this wave pattern is 100% precise, even more precise than scanning a barcode, that it will read whether the hydrogen electron is spin up or spin down. So if you have a computer with 8 hydrogen atoms as qubits, then it's my guess that the laser light will push the electrons into the conduction band, and you will be able to read on a screen at the back of the qubits the spin state of these electrons. In other words, the wave pattern for a precise 8-bit binary number will appear on the screen. If you have a system with 16 qubits, you will get a 16-bit binary number, and so on. So far, so good. But now comes the magic part, the DNA phantom effect. If you remove the physical sample of DNA and shine the laser light through the space where it was, another wave pattern appears on the screen as if the physical sample was still there. If you want to know more about this, you will need to read the book, The Spiritual Genome, and the journal article, The Evolution of Consciousness, available at www.spiritualgenome.com. But the point is that this new phantom wave is actually the probability waves of quantum mechanics. In this context, you also need to know about the memory of water. In fact, there is a research paper by Nobel laureate Luc Montagnier entitled DNA Waves and Water, which actually reproduces the Russian findings about the DNA phantom effect. In fact, in vivo, water and DNA are inextricably combined. It's the water that actually causes the DNA molecule to twist into its characteristic helical shape, because the nitrogen elements are hydrophobic to keep the water from entering the middle of the molecule, and the DNA can only act as a conducting nanowire when it's in its helical shape. And the sugar phosphate backbone of the DNA is not only hydrophilic, but is actually soluble in water. Externally, the DNA molecule becomes a liquid medium, and this is how the water surrounding the DNA can actually retain the probability waves in the DNA molecule. These holonomic gates seem to be the answer to everything. The researchers say, we manipulate purely the geometric phase with a polarized microwave in a nitrogen vacancy center in diamond under zero magnetic field at room temperature. We also demonstrate a 2-qubit holonomic gate to show universality by manipulating the electron nucleus entanglement. Diamond, of course, is carbon, and they must have doped it somehow with nitrogen. And they use polarized microwaves to manipulate the geometric phase of an electron or nitrogen nucleus. It's my bet that this can be done with highly polarized laser light to manipulate the electron nucleus entanglement of a hydrogen atom as well. Dr. Garyev, one of the Russian researchers, states that the chromosomes in vivo act as a solitonic holographic computer by means of the endogenous DNA laser light emissions. When I read this, I remember puzzling at the time what this word solitonic meant. It's my belief that these solitonic waves in the DNA are produced by holonomic quantum gates. Solitonic means a single photon emission, which by definition will have 100% precise frequency. You will also need to look at this process known as DNA origami. The semiconducting properties of DNA make it ideal to make nanoscale integrated circuits. The DNA molecule is just 2 nanometers in diameter and can be folded into any desired shape. The folded DNA is used as a scaffold on which to mount nanoscale components such as electrically conducting carbon nanotubes. I think it's going to be possible to actually use the DNA molecule to make the CPU for a quantum computer. What's more, it has been proposed that the DNA can be used as hard drive data storage for quantum computers. In a paper published in the journal Science, scientists from Columbia University and New York Genome Center demonstrated that a single gram of DNA can potentially store up to 215 petabytes of data. That's 215 million gigabytes. Theoretically, that's comparable to the data of the human race being stored in a container the size of a couple of pickup trucks. So we have a situation here where all the evidence suggests that we will be able to build a quantum computer modeled on the DNA, where not only the semiconducting chip can be made of DNA, and the qubits can be manipulated and read using laser light, also known as spectral lines of atoms, exactly as it is done in the DNA, but also the data can be stored in a hard drive composed from DNA. How easy is that, you may ask? It's obvious. But are the quantum computing researchers excited? No, they are not. The fact is they have got grants of tens of millions of dollars to build these cumbersome, complex and totally impractical quantum computers operating at near absolute zero temperature. And their knowledge of the DNA and quantum biology is also nearing absolute zero. The last thing they want to do is try to sell all that equipment on eBay and actually start working with the DNA. Yuck!